For the purposes of pharmaceutical calculations, the values for specific gravity and density are interchangeable. You use them both the same way for the same problems. The only difference you need to worry about is that specific gravities are reported without units and densities are reported in grams per milliliter. You use specific gravity and density to convert between the weight and the volume of a liquid. For example, if you have a situation where you need 20 milliliters of a liquid, but need to know how many grams that represents, you could use the density or specific gravity to solve that problem. On the slide, you can see that a liquid chemical we've called pink chemical has a density of 1.05 grams per milliliter. This is true because 1 milliliter of the chemical, when placed on a scale, weighs 1.05 grams. And so you can use this relationship to convert between milliliters and grams of pink chemical. You can also find specific gravities and densities for solutions, even though solutions consist of multiple chemicals. This second example shows how 1 milliliter of a 10% weight per volume solution of pink chemical dissolved in water only weighs 1.01 grams, making its density 1.01 grams per milliliter. Water, by the way, has a standard density of exactly 1 gram per milliliter. Pause the video for a moment and see if you can come up with answers to the two questions at the bottom of the slide. Okay, the answer to the first question is 1.05 grams. You should be able to see this by just looking at the density value for pink chemical. It shows that there are 1.05 grams per 1 milliliter. The answer to the second question is 101 grams. This involves a quick proportion where we scale up the density of the 10% pink solution from 1 to 100. So instead of 1 ml of pink solution, we have 100 ml of the solution, and we want to know how many grams that represents. So 100 times 1.01 gives 101 grams. Let's take a look at how we might use specific gravity in a percent concentration problem. Sometimes when a problem involves many different values, it's useful to map out what you want to know and what you're given before attempting to solve, and I think this problem is a good example of that. If the specific gravity of a pink chemical is 1.05 and the specific gravity of the 10% pink chemical solution is 1.01, how many mils of pink chemical are in 100 mils of 10% weight volume pink chemical solution? So what we want to know are mils of pink chemical. What we know are the 100 mils of pink chemical solution. That's the total volume of the solution. We know the concentration of the pink chemical solution. And then we're given specific gravity or density values for pink chemical itself and for the solution. So thinking about this for a minute, you can see that given a volume like this and a concentration like that, we can at least figure out how many grams of pink chemical are in this solution. Setting up a proportion like this, if there are 10 grams of pink chemical in 100 mils of solution, how many grams of pink chemical are in 100 mils of solution? Well, you don't even have to crisscross for that. There are 10 grams of pink chemical per 100 mils of solution. Great. So we know the mass of pink chemical. Now the question is, how many mils of pink chemical are there? Well, that's exactly what density and specific gravity are for. They're to take the mass of some substance and convert it to the volume of that substance. And so which do we use? Do we use the density of pink chemical or the density of solution? Well, it should be obvious that since we're wanting to convert the mass of pink chemical to a volume, we should use the density for pink chemical and not for the solution. So we can set up a proportion where we have 1.05 grams of pink chemical per mil from its density, and so how many mils is 10 grams of the pink chemical. Crossing, dividing by 1.05, we get 9.52 mils of pink chemical in 100 mils of that solution. In these two example problems, we're going to make changes to the units that make up the percentage strength. The principle is still the same though. We're going to still use densities or specific gravities to interconvert between milliliters and grams. So the question asks, what is the percent volume of a 2% weight per volume drug solution? The density of the drug is 0.92 grams per mil. Density of the solution is 0.98 grams per mil. So what we have is a weight per volume percentage. What we want is a volume per volume percentage. The weight per volume percentage is 2 grams per 100 mils. The volume solution, we don't know because we don't know how many mils of drug are in 100 mils of solution. So we have the volume on the bottom, but we don't have the volume on the top. To solve the problem, we're given two different densities, one for the drug and one for the solution. So if we want to convert grams of drug into mils of drug, which one would we use? Obviously we would use the density for the drug and not for the solution. The solution's fine at 100 mils for a volume measurement. We need to convert the drug from grams to mils. So setting up a proportion with this density, we have there are 0.92 grams of drug per mil of drug. So how many mils of drug are represented by the 2 grams in the problem? Crisscross. Divide by 0.92. Answer is 2.17 mils. So that tells us that if there are 2 grams of drug per 100 mils, there are 2.17 mils of drug per 100 mils. We can divide and multiply by 100 or just use the value. It's 2.17% volume. In the second problem, we want to find the percent weight per weight of a 2% weight per volume drug solution. Specific gravity is 1.2. That's for the drug. Specific gravity for the solution, a 1.12. And what we have is a 2% weight per volume solution. That's 2 grams of drug per 100 mil. What we want is to know the grams of drug per grams of solution, weight per weight. So in this case, the grams of drug are fine. We need to convert the mils of solution to grams of solution. So it's really similar to the above, but this time, this is a case where we would use the density or specific gravity of the solution. So 1.12 grams of solution per mil of solution. How many grams of solution are represented by 100 mils? Answer is 112 grams. So we can go ahead and change this concentration expression to there are 2 grams of drug per 112 grams of solution. That's 0.018. Multiply by 100 and we get the percentage 1.8%. All right, it's your turn to do some weight volume conversions. See if you can do the problems on the next slide before checking out how I do it in the next video.